Today we are going to be building an exclusive OR gate. The materials covered were in the couple of slides before. Now let's get straight into the process of making it. To set up, take your small wires and connect negative on one side of the power rail to negative on the other side of the power rail, the parallel negative power rail. Do the same with positive. This allows power delivery into both power rails. Make sure you have all of your wires attached together like this. Your male-to-male wire and your female-to-male wire should be inserted into one another like this. Do this 5 more times so you have 5 sets. After that has been completed, let's connect the power from the microcontroller to the power on our breadboard. Taking one set of the wires that have been attached together like this, plug one end into any positive power rail hole. Plug the other end of the plug the other end of the wire into 3 volts. It should say 3V in over here. I think it's a little blurry, but you should be able to see it. 3 volts is right around here. 3.3 volts. You can use 5 volts if you'd like, but I'm just using 3.3 volts just to be safe. Repeat those instructions with the negative end. Plug one side into any negative power rail hole, and the other side into GND. It should be right beside 3 volts or 5 volts. As you can see, it's highlighted over here. Plug it into any one of these 2 GNDs. I'll just pick this one. And there you have it. Your breadboard will now have power. Let's move on to the assembly. Let's begin the assembly process. Insert 2 buttons into your breadboard like so. Two of the teeth of your buttons should be on one end of this middle gap, and 2 teeth should be on the other end of this middle gap. Once you have finished that, take one of your 220 ohm resistors, connect it in series with the top right pin on your breadboard, like so. And then directly connect that to ground, which is negative. Connect it to any hole on the blue power, on the minus power rail. Some breadboards, it might be black or blue, that still represents negative. Do it like so. Next, take one of your sets of wires, your joined sets of wires, plug one end diagonally opposite to the resistor connection. So as we plug it into the top right here, we should plug it into the bottom left here, anywhere along this line. So let's do that. Plug it into this, plug it in here. Take the other end of the wire and plug it into any PWM pin on your microcontroller that you would like. Me personally, I'm going to pick pin number 11. Let's repeat those steps with the other button. Once again, take a resistor and connect any end. I'm going to pick the top right end directly to ground, which is negative. Once again, it can be blue or black, but make sure to connect it to a blue or black power rail, like so, like this. Once again, you're going to want to connect your button. You're going to want to add the extra wire on the diagonally opposite side. So in this case, it's on the top right. You're going to want to put it on the bottom left. So take one of your joined wires, plug it into the bottom left section, and plug the other end of your wire directly to any pin you like, any PWM pin. I'm going to pick pin number 10 because it's right beside 11. Now, let's move on to the LED. To provide an unobstructed view of the breadboard during this section, I will be removing these 2 wires. Make sure to attach them back at the end. You do not have to do this step. Remove the 2 wires. And now let's work with the LED. Split your LED like so, where 2 legs have a gap in between them. The longer leg is your positive side. Remember which side you put the positive leg on. For me, I'm going to be connecting the positive leg on the left side and the negative leg on the right. This, hope you guys can see that. Just making sure. Yep, the shorter leg is on the right side, which means the negative leg is on the right. Connect the negative side, which is the right in this case, directly to ground using a 220 ohm resistor. This part isn't mandatory to use a resistor, but it is highly recommended to do so to prevent your LED from burning out. So do that if you can. Now take your final wire that has been attached like this. Make sure the connection is secure. Connect one end to the positive leg and connect the other end to any pin on your microcontroller that you would like. I'm connecting it to pin number 12. Now let's reattach the positive and negative connections. And now we are ready to begin the programming. Let's go.
Hey there, I hope the assembly process was easy for you. Now, let's get started with the programming. So, there are two main sections in an Arduino program. There's the setup section, code that runs once directly after running, and there's a loop section, code that keeps running over and over and over again right after the setup code runs. All this code will be based off of the Elegoo Uno R3, which is a copy of the Arduino Uno R3. This code should work on both boards, but I don't know about any other Arduino boards. So, to begin the setup, we can say serial.begin 9600. This starts communicating from the board to the computer at a 9600 baud rate, which basically means that at a rate of 9600 bauds, the board will be transmitting information to the computer. Let's add a semicolon at the end of every line to make sure it works, because this is heavily based off of C++, and C++ requires you to do so. Let's initialize all 3 pins. If you remember, pin number 10 and pin number 11 were set as input pins. So let's set them as input pull-up. Pull-up pins are basically like resistors. When current is flowing through them, they're switched to a low state. But when there's no current flowing through them, there's a high state. It's set to a high state. Once again, let's add a semicolon. And if you're doing the development in Visual Studio Code, you will see error lines underneath every term as it's thinking it's a C++ program, where it's actually an Arduino program. This is completely normal and you have nothing to worry about. Let's repeat these steps with pin 11 as well, as that was also another input pin. And pin number 12 is our output pin. So all we got to do is write output. As simple as that. Let's just put some example here. Same with pull up down here. Now, let's finish. We're done the setup code. This code will run once and only once after the microcontroller starts receiving power. Now let's do the loop. This set of code will be running indefinitely until either power is stopped or some other instructions are given to the board. Let's create a Boolean object. A Boolean, if you don't know what that is a true or false. If it is true, it's represented as 1, and if it is false, it is represented as 0. Let's create a Boolean called B10, as in the button into the 10th pin. Digital read 10 pull up. What this does is that it will allow the microcontroller to read what is happening on that pin. If basically the resistance is put all the way down to low, meaning that current is flowing through the resistor, through the pull-up resistor, then this will be toggled as low, which if it is low, B10 will be toggled as true. If this. Let's repeat the same with button 11, button for pin number 11. Make sure to add semicolons at the end of every single line. Now let's add an if statement. An if statement will will take an argument and it will return true if the argument returns as true. So if we have if B10 caret B11, caret is the exclusive OR operator. If one is true and the other is false, then it will work. Only one of the two inputs must be true for it to work. If both inputs are true or both inputs are false, this will not work. It will be false. Now let's just add this bracket like this. The caret operator, which is the up arrow, this character over here, that represents exclusive OR in many programming languages like Python, C++, etc. Now let's say if B10 exclusive OR B11, meaning if one of the two buttons is being pressed down, if one of the two pins is receiving input, then let's set the voltage of pin number 12 to high. So it starts delivering power to our LED light. Digital write will basically tell the pin how much power to start delivering to the connection. So if it says high for pin number 12, then that means pin number 12 will start outputting a high voltage. Now we can do this, serial.print exclusive OR has been triggered. So we can see something on the serial monitor. It's basically like a command line. We can see it on the serial monitor that XOR has been triggered. It will say it all the time whenever the condition is true. Forgot the semicolon, make sure to add the semicolons. Now let's put an else statement, just in case both buttons are being pressed down or no buttons are being pressed down. Let's write the pin number 12 to low, so the voltage goes back down to 0, or goes to near 0. And that is basically it. You are done with your program. Now, plug one end of the wire that came with your microcontroller into the microcontroller, the large and the square one, and plug the USB end into your computer. After you have connected your microcontroller to your computer using the provided USB cable, make sure to copy and paste your code from Visual Studio Code into Arduino IDE. You can also directly develop an Arduino IDE, but I prefer developing in Visual Studio Code as the theme is easier on my eyes. Just wait for the index to download. Paste the code for now, and at the top it should say select board. It should say select board. Select Arduino Uno. It might show COM1, might show COM2, might show something else. Make sure you pick Arduino Uno. It might not always be COM3, but make sure it says Arduino Uno. Click on it, and now your code is ready to be flashed onto your Arduino board. Press this button, upload, and the command line window should show up. An output window saying sketch uses how many ever bytes of program storage space, maximum is those many bytes. All this will be shown, and now your code has been flashed onto your Arduino. Let's take a look.
After the code flashing process to the microcontroller has been completed, a light should briefly flicker and it should come on like this. There should be an on light over here, and there should be an output as shown before. Sketch uses how many ever bytes of the program storage space, whatever is written here. The numbers don't have to be exact and the percentages don't have to be exact, but you get the point. It should be somewhat similar to this output. Let's open the serial monitor. Now, serial monitor, 9600 baud rate basically means it can receive 9600 bauds or 9600 bits. The serial port on this microcontroller is capable of transferring 9600 bits a second. Back to our creation. We have two buttons. One button, when pressed down, will allow the light to glow, and the other button will also allow the light to glow. When none or all buttons are being pressed down, the light will not glow. Watch. This button is being pressed here, the light glows. Button is pressed here, light glows. However, if you press both buttons at the same time, the light turns off. Now, I'm going to let go of a random button. Let's say right. Light comes back on. Let's try that again with the left side. Again, light comes back on. Now, as you can see on the serial monitor, this is what receives all the information from the microcontroller. So this serial.print will be communicated from the microcontroller to the computer, and it should show up in your serial monitor. Let's just add a new line character here. Save the code. Let's flash it one more time. Code has been flashed. Now, if we have a look at our serial monitor, while triggering one of the buttons, exclusive OR has been triggered. Second I let go, it stops. Once again, when I press another button, more exclusive ORs have been triggered, are popping up. They're just going down and they're not being rendered exactly, but you see it. Thank you for watching this video. I hope you've had fun designing the exclusive OR gate with me. And please like, share, and subscribe. See you in the next video.